Okay, hello and welcome everyone to this month's webinar. For anyone who doesn't know who I am, I'm Sasha Demian, the Executive Director of the MBCEA. We are going to ask everyone to remain muted during the presentation just so that we don't have any background noise that is distracting. Before we get started, I wanted to remind you that we have an open survey in the MBCEA mobile app right now for categories that our contractor and erector members specialize in so that they can be more easily filtered in the member directory. So please complete that survey in the app if you have not done so yet. We've also opened up advertising in the app in the newsfeed section. And recently I sent out an email with some picture and video assets needed for the metal building curriculum courses we're creating. So if you can assist with any of those, please let me know. And lastly, save the date for next month's session in our webinar series. It will be presented by Lee Shoemaker with the MBMA on the resources that they have available for metal building contractors and erectors, and specifically a review of their common industry practices. So watch for that invite. It is going to be the beginning of October, and I believe it will, I should have written it down, but yes, Tuesday, October 8th is when that will be. Now I would like to introduce Robert Tiffin, President of the MBCEA, to introduce our sponsor and speaker for today's presentation.
Perfect. Thank you, Sasha, and good afternoon, everybody. And just a reminder that this is the latest installment of the national meeting. So for all those folks out there that are part of a committee or part of a state chapter, welcome. For those of you that are trying to build a chapter, we hopefully today will give you some content where people are gathered around a laptop and perhaps a sandwich to start to build the camaraderie across the country. But without further ado, I'd just like to say thank you to our sponsor of today's session, Advanced Glazings. I'd like to introduce Joe Menchefski, who will present on balancing light and life in today's built environment. This is an AIA-approved course for HSW credits, so please be sure to let us know in the chat if you qualify for that learning certificate. Joe Menchefski is a chemical engineer with an MBA in marketing. In the late 1990s, he ran an extrusion operation to produce multi-walled and polycarbonate, which eventually led him to the world of glazing and ultimately to daylighting. Joe took over as the VP of Sales and Marketing for AGL in 2005. Since then, he's been a shameless lover of all things architecture and a vocal daylighting enthusiast. A highly entrepreneurial leader, Joey has now launched 3 companies, including a firm that designs and manufactures scent-free cleaning products for schools and hospitals, a medical nanoparticles research company that is currently traded on NASDAQ. Joe's passion for sustainable design and occupant comfort has only grown stronger over the years, culminating in the creation of better buildings for humans as the ultimate vehicle to engage in conversations with the thought leaders driving the creation of healthier, more beautiful, and more sustainable buildings. Joe, the floor is yours, and thanks for joining us.
Thank you very much, Robert, and thank you very much, Sasha. And hope people will tune into the Better Buildings for Humans podcast. It's been a lot of fun and a real adventure. So I'm going to assume that the people who signed up for this session today are interested in creating higher value buildings that command higher margins. This presentation is not about the cheaper, faster, but it's about learning a couple of simple ways to create better buildings while staying within the low-cost paradigm that's so important to this industry and that's made the industry so successful. So let's dive in. This is an AIA accredited presentation, so if we have any architects among us, we can provide you with the learning credits. The metal building industry is an absolutely perfect example of what they call technological disruption. And you hear that word a lot these days. But if you go back to the original book by Clayton Christensen called The Innovator's Dilemma, he talked about the idea of an industry or a company that starts with an application. They get launched with an application that have really low performance requirements and correspondingly low cost as well. And they outperform with those at those lower performance requirements. And over time, they start adding features, they start getting more sophisticated. And, as they say, you start to swim upstream. In this industry, you look at some of the things that are coming out of the MBMA these days, it's just getting so much more sophisticated, so much more complex, and the applications are moving up to the higher end. So in order for an industry to continue to swim upstream, you got to give the customers what they want, And how do we do that? Well, there's several ways in this world. One thing is to make buildings that are just more beautiful, more attractive. Another way is to get buildings that are more functional, that can do more, that work a little bit better. A third is to get into the green movement, the buildings that are more sustainable. And then a fourth is to build buildings that are better designed for the humans inside the building, right? They're more friendly for the building occupants. And the good news is there's a way to do all four of those things simultaneously, and it's all about the building envelope, right? In other words, it's about managing the connection between the people inside and the outside world. Now, let me explain that a little bit. If you look at this graph, right, and we've got connection level on the x-axis and quality on the y-axis. Let me tell you what that means. As you go to the right, you have higher and higher levels of connection between the people inside and the people outside. So at the far left, you've got the dark boxes, right? The buildings that have no punch outs, that have no windows, that have no real connection between the inside and the outside. Typically a lower quality building, a lower price building. And then you go, all the way to the extreme, right? We don't see that much in this industry, but in, some more architectural applications, basically it's the all transparent glass building. The connection level is very, very high, equally problematic. And let's talk through that. First, the low connection buildings. These buildings are very, very practical and very good with thermal insulation, but they're not very particularly exciting. They are not a move upstream. They that the isolation of the humans from the natural world can actually reduce our level of health, and they reduce our level of energy, and all of this would be proven. I can share all this. Anybody wants the links, I can show you how significant the impact is on people in these buildings. So if you need people to be productive and creative, and you need customers to linger for a long time in your building, these are not ideal. Just some more examples. These aren't metal buildings, but when you get into where we are with building codes today, and they're driving us down to this sort of 30% window to wall ratio, these are the kinds of things you end up with. Imagine living in a community entirely built of buildings like this. Now let's go to the other extreme. These are the term they talk about is the term they use is fishbowl, right? So completely transparent glass buildings, which can be gorgeous and they're really exciting and all that sort of thing. They've got their issues too at this other end of the spectrum, right? Too much connection. Let's look at all the things that come with too much connection. One is thermal discomfort, right? So when the sun is shining, we've all sat in the airport and had half of our faces burning from the radiative heat from the sun. And in the wintertime when it's cold, they don't have much insulation, so it's very comfortable when you're uncomfortable. Sorry, it's very uncomfortable when you're at the perimeter of the building. Of course, there's no privacy with that much glass. You're not even going to meet building codes with that much glass these days. Glare is a huge issue, and I'm going to talk about glare a little bit during this presentation. But glare is absolute brightness, but it's also about when you've got bright and dark together simultaneously. Bright, the hot spots as we call them, that can be very problematic as well. And that glare will lead to those glass buildings being completely covered in blinds, and blinds are not without issue, right? People say, well, just put the blinds up. Well, when you put the blinds up, you've got the cost of putting up the blinds, you've got the ongoing cost of maintaining the blinds, and you no longer have any natural light in the building because the blinds are pulled. You just have to turn on the artificial light. And you also don't have views anymore, which can be very important as well to the health and productivity of the people inside the buildings. Okay, so why do we end up with so many buildings that are at these two extremes? It's because the materials that we've had for so long for constructing these buildings are binary. In other words, you've got materials that are either opaque or they're transparent. So they let no light in, or they let in extreme levels of light. When you look at all of the things that you want to have in a good building envelope, right? And I'm assuming a higher end building where you have people occupying the building on a regular basis, and that you want them to be productive, you want them to be healthy, and you want them to linger, right? Now, given those things, right, let's look at a few of these parameters that really matter to a good building envelope. Are we providing views? Opaque's not going to do that. Transparent is. Thermal insulation, opaque is going to be there for you. Privacy as well. Not very interesting. They tend to be a duller building, not a higher value building. Thermal insulation is not there with transparent glass. Neither is privacy. It is interesting though. Neither of the two components that we have now provide great natural light. Obviously, the opaque's not going to provide any light, but transparent is going to provide light that comes with glare. So it's not really giving you the great natural light that a lot of us know is important these days, right? But what if we had a third option? This is where we're talking about some changes to the building envelope. And some of this is happening now. But this is a way of doing it more often with class, right? So the when you look at the boxes that we're trying to check for opaque and transparent, we never got there with great natural light. But if you add a translucent glazing material, right, something that excels in natural light, excels in thermal insulation, really has high levels of insulation. So you're going to let light into the space. It's going to be light that's going to be glare free, and it's going to help you meet building codes as well because of the high levels of thermal insulation. If you look at the transparent glass and the ideal translucent glass together, right, you can check all of the boxes. You've got views, you've got great natural light, you're going to have the thermal insulation, the privacy, and of course, it's going to be a much more interesting, higher quality building. All right. Let's very quickly look at some examples. This arena in the upper right-hand corner, that entire massive space is being fully illuminated with no artificial light, with just 6 feet of clear story around the perimeter. Down the bottom, we see transparent and translucent working together. The translucent is bringing the natural light into the space. The transparent is providing the views, and they work together to do that. The translucent at night is the light entering the building is being diffused and softly, but the light exiting the building is as well. So you can have this sort of lantern effect that makes your building become sort of a centerpiece. Now, you can also use the translucent to frame your views. This is very high end when you get into some automobile dealerships and create very beautiful soft light inside. Okay, excuse me for just one moment. I am having a minor technical issue that is now resolved. Okay, closer look at translucent glazings. How do we choose which translucent we're going to use in order to achieve all these things? We're going to look at 4 products or 4 families of products. An acid etched glass, a white laminate glass. We're going to look at FRP and plastics, which are popular in this industry. And we're going to look at a glass-based translucent glazing unit, which takes it up just a notch. And how am I going to say? Why do I say takes it up a notch? We're going to look at all 4 of these products in terms of these 3 criteria. First, insulation value. Second, the ability to diffuse light and control glare. And third, aesthetics and longevity. All right. Very quickly on insulation, vision glass, acid etched, white laminate, none of them are going to have a high enough insulation value that they start to allow you to eliminate a portion of the opaque component of the building envelope. Only plastic and glass-based translucent engineered light diffuser are going to get you there. Now, let's talk about diffusion. It's got to diffuse, any glazing that you're going to use for the purpose of bringing natural light into a space has got to have a high amount of diffusion. I see a chat there. I'm going to take a quick look. Love when anyone says insulation. Yes, well, kind of have to these days. It is a critical component of any new building these days. So light diffusion power, let me introduce that for you. So first of all, vision glass, in order to see through it, it can't diffuse the light at all, right? Which is why you have the ability to have a view, but it's also why it's not very good for use it for bringing light into a space for the purpose of the sun being your illumination source, right? And if it diffuses poorly, it can actually be more problematic than the transparent. In order to diffuse properly, you need to have a high light diffusion power. In other words, you need to spread the light evenly in every direction. And let me explain light diffusion power. I'll go quickly on this. It's not as complicated as it initially seems. So here's the experimental setup. You take your glazing material, whatever it is, and you put an opaque backing on it. Cut a little hole in it, right? And shine a light down, any light at 45 degrees. Measure around the 180-degree arc around the back here and find out where the light goes. That's all you're doing. Where's the light go when it passes through the glazing, right? Transparent glass is going to do exactly what it's supposed to do. The light shining down at 45, it's all going to land at minus 45. You're going to get that hot spot. Going to be very difficult to work in this office. By the way, the image at the top, that is what's called a photorealistic rendering. It's from a lighting modeling tool. And then the bottom is what's called a false color rendering, which shows you, uses color to show you how bright it is in that spot. So you got that super bright spot, those sharp lines. We've all seen the hot spots, right? Acid etched white laminate glass, you can see from, especially from the false color renderings, you are getting some level of diffusion. The lines aren't as sharp, but you're still getting the hot spot. You're still going to get that bright spot. You're going to get some visual privacy, but you're not going to get good, even distribution of light. This is what a good light diffuser looks like, right? So when the light hits the glazing sample, it then moves in every direction simultaneously. And there's two advantages to that. First and foremost, you don't get the bright spot, it's gone. But secondly, the light that's going above zero, that's light that's going upwards. Okay, so instead of hitting the dark floor, it's going to hit the ceilings, it's going to hit the walls, and it's going to push deeper into the building, which means that you can illuminate or bring natural light into much more of the building from the wall instead of having to put skylights on the roof, right? Unless you got a huge floor plate, you can bring in a whole lot of light from the vertical instead of having to do it from the roof, which is hugely advantageous in this industry. Right. So just a quick summary, acid etch, or sorry, with vision glass, you got that really bright spot with the nice square edges. Acid etch, you still get the bright spot. It's just the edges are a little softer, but with a glass-based translucent glazing that's made for softer light, you're going to get a really nice even distribution, and it's going to penetrate deeper into the building, right? So in other words, the bottom line on that is you're going to have to use high light diffusing glazing, a glazing with a high light diffusion power in order to achieve having the sun become the illumination source, the free light from the sun become the illumination source in the building. And if you get it wrong, like this is an example of a high school where they used acid etched, gets completely covered with blinds, you no longer have natural light, you no longer have views. Okay. Now, the third criteria we want to use for evaluation of the ideal translucent is how long it lasts and how good it looks. All right. Almost everything looks good from the beginning, but over time, it doesn't look so good, right? The longer the product lasts on the building, the less replacement it needs, and the lower the overall cost is going to be to the building owner, right? Acid etched looks good, is going to last a long time. White laminate, depends on who you talk to. I think it looks good, and it also has the longevity, but you don't have the insulation and you don't have the light diffusion. A good glass-based translucent glazing, you're going to have it, it's going to look as good in 50 years as it does when you put it in. Plastics look great at the beginning, but over time things shift. And there's a lot of applications where that's okay, where you don't have people in the building, where the appearance of the building isn't that important. Fine, that's a good application for plastics, right? But if you're going to have people in the building and the appearance of the building matters to your customers and to your community, plastics are just not going to cut it, right? We've all seen this. I don't have to go into too much explanation. We've all seen plastics that have degraded over time. This is the same university. One section of it, they're using an FRP, and then another section, they used a glass-based translucent. The 23-year-old glass-based translucent looks exactly the same as the day it was installed, right? how does that affect the inside of the building? You're looking at a multi-stage renovation here. On the right-hand side, they've still got the aged plastic. You can see the yellow hue that it's casting, whereas the glass-based light diffuser is going to give you a nice bright white light forever. Okay. Total cost of ownership, every time you have to do a replacement, your cost goes up, right? And based on the way prices have climbed, over the last 50 years, if you project that forward, you're literally looking at, sometimes 3-4 times the cost because of the regular replacement every 20 or so years. All right. I've had people on a regular basis come up to me and say, why don't we just use LED lights because they're so cheap these days? There's two issues. And I live and breathe this stuff, so it's not, it's easy for me, but it's not everybody sees the sort of information that I see all the time. LED lights are not full spectrum, right? So you're missing some very important parts of the light that are critical to human health, things that affect our sleep, things that affect our energy levels, that are not there with LED lights. So eliminating natural light is not a good idea when you have a lot of building occupants and their productivity and creativity matter. The other thing is that the calculation for LED lights being cheaper, just put opaque walls and don't bring in natural light and use LED. The calculation on that assumes that you're using an R2, maybe an R3 glass. But if you get into an R12 glass, an R18 glass, which is what I'm talking about today, that math doesn't work anymore. It's actually cheaper to use the glass-based translucent. Okay. So in conclusion, acid etched white laminate, they last a long time. They look good. They don't have the energy performance, and they don't diffuse light well enough to be used for the purpose of bringing light into a space. Plastics, they just don't have the lifetime. They don't have the longevity. Whereas a glass-based translucent achieves everything you need. You're going to end up with the right connection level. If you get the right amount of translucent and the right amount of transparent and the right amount of opaque, and you get that ratio right between the three of them, then you've got the right connection level, right? So you can create beautiful spaces like the one on the left, right? Or dark boxes like the one on the right. You can have the superheated solar collectors with too much glass. And, yes, it does kind of matter in this industry because you've got a lot of, reception areas and atriums that we're putting onto buildings now, especially in the large sports facilities. You can create these really uncomfortable situations, but you can deal with that very easily just by swapping out some of the transparent glass for translucent. Okay, we've all seen this. We've all seen the hot spots. Because transparent glass doesn't diffuse light, all the light falls in one place and the rest of the space remains dark. It's not the way to bring natural light into the space. The good news is you don't have to do a lot of the crazy stuff that you've been told you have to do to bring in natural light. You literally just have to swap some of the transparent glass for translucent glass. Okay, that's the end of the AIA portion. Everybody who survived with me thus far, if there's any architects there, like I said, you've achieved your credits. I want to mention the company name now and the product. Advanced Glazings makes two products, Solera and Solera Wall. They're both very similar. How do we achieve light diffusion and how do we achieve really high levels of insulation, right? At the end of the day, it's an IGU. It's two panes of glass separated by a spacer, right? But it's what we put between the two panes of glass that gives it the really great properties. You put a glass fiber veil. We bond a glass fiber veil to surface 2 and a surface 3, to the inside of the unit, the two surfaces that face each other. That glass fiber is where you get your diffusion, right? Separate from that, we also put in what's called a honeycomb, which is basically a bunch of little square pockets. And those little square pockets stop the movement of gas between the two panes of glass, or they restrict it severely. And that's the way you can get such high levels of insulation. But hey, now aerogel is commercially viable. You can't just stick aerogel between two panes of glass because it settles. By the way, for anybody who doesn't know, aerogel is the most insulating material known to human beings, and it also lets light transmit through. So if you fill the little pockets in the honeycomb with this aerogel, You can get super, super high levels of insulation, like R18, R25 levels of insulation. Sometimes you need a thicker pane of glass, and which is why that thicker spacer is there. And I'll come back to that, I promise. But now you understand the glass fiber veil, there's the diffusion, the honeycomb, and the aerogel give you that really, really high levels of insulation. Now, what about vision? People want to see out, right? Especially you got lots of people in there. We say that vision sorry, let me rephrase that. We are the guardians of vision. Solera and transparent in combination keep the blinds off the window. Let me explain that one. Transparent glass, all the light passes straight through. It has to. It all falls in one place and the rest of the room stays dark. Translucent, the light strikes it strikes the translucent glass and it spreads evenly within the space, right? But you can't see through it. But if you put the two of them together in the right ratios, right, the translucent brightens the room, right? It spreads evenly, it brightens the entire room. So even though you've got a hot spot forming, the brightness of the hot spot is not as bright because they're relative to the rest of the room, right? The ambient light level in the room is very high, so the hot spot doesn't matter as much. It's all about contrast. If you got really bright and really dark together, it's very uncomfortable for people. But if the room is really bright, the hot spot doesn't seem as bright. And you can get a very comfortable space and you won't feel the need to put blinds on the transparent part because everything is so nice and evenly lit that you're not experiencing the glare. I hope that makes sense. Stop me if it doesn't.
No, it
Okay.
does. It does, Joe. Thank you.
Okay, perfect. So modeling, I'm not sure everybody here has been exposed to daylight modeling or light modeling. I'm gonna show you a couple of examples, like the one that's up here already. I'm gonna show you what, original designs and with transparent glass, a portion of the transparent glass being replaced by Solera, and then an actual photograph of the image. So this one is that ice rink I showed you earlier. In the original design, they had 6 feet of transparent clear story. That glare pattern is going to be a really serious problem. The bottom image is the photorealistic rendering from the daylight modeling, and you can see that the problem is gone. And when you see the actual image of that very large space, there's not a single artificial light on here. That entire massive space is being daylighted with just 6 feet of translucent clear story. This is a school library. They put all glass on the ceiling. You can see the glare pattern is going to be just unacceptable. Replace it with Solera. You still have the full spectrum light and all the health benefits and productivity benefits that come with it, but now it's a place that they can actually learn. We do a lot of work in schools, by the way. We do a lot of work in gymnasiums because it's been shown that kids do so much better when they've got natural light in the classroom, that pretty much every school being built in America and Canada now have light coming into the classrooms. Right. This is a very classic sort of situation. School gymnasium, they put in a floor-to-ceiling curtain wall because they wanted the light in the view. They were going to have such a serious glare problem that they would have ended up with floor-to-ceiling blinds. So they modeled it with Solera in this top section, glare problem solved. And look how nice and bright the room is. The modeling is showing light bouncing off the ceiling. Here's an actual photograph, light bouncing off the ceiling. There's no artificial light in this picture. This is a really old one, by the way. You can see from the fluorescent lights, but I chose a really old one for good reason. First of all, it's a really good example, but secondly, to show you that stuff has been around for a long time and you're not really going out on a limb at all. We're talking, 25 years. This job is without compromise, right? Like you got the transparent glass down at the floor where the people actually are. So you've got the view that you need. You've got the translucent bringing in all the natural light to save you a lot of money, plus to make it better for the kids. And the translucent has a very high level of insulation, so you're still going to be able to meet all your building codes. All right, large spaces are the killer app. I stole that from the tech world. In other words, what's the perfect application for a good translucent? It's big spaces, right? We do an extraordinary job daylighting or using the sun as the illumination source in really big spaces. We do a ton of that. right? And I know in the metal building world, there's a whole lot of these kinds of spaces. There's that glow at night again, right? And this is probably a little more typical for us. I show some spectacular images, but this is the bread and butter stuff, right? This is the ordinary day-to-day school gym that we do all the time. Right, and recently did a project with Bombardier building airplanes up in Toronto, Robert's old stomping ground. So had to show that one off. Really brightly lit space. They just moved their manufacturing operation to the airport, Robert. I'm not sure if you heard that, but very interesting move. So again, all you have to do is swap out some of the transparent glass for translucent, and we can show you for free. We'll do the modeling, right? And show you what percentage of it you would need to swap out. Now, you can use a glazing contractor to do the install, but what most people are doing now is we're partnered with Wintech in out of Missouri. I'm sure most of you guys are familiar with Wintech, and we can put our units in a Wintech frame and just ship completed windows to you for punch outs or for ribbons or for clear story, and it works with both corrugated or IMP. All right, this is just to show if you needed to use a glazing contractor, say it was a storefront application or a curtain wall application, we've got a Solera that'll work with every one of those. What about that really visionary customer, the one that really wants to build a truly spectacular building, right? Something that's very extraordinary, but also higher performing, right? Let me introduce you to Solera Wall, right? Solera Wall does not need any framing system. Everybody's familiar with IMP. They click together. They have parts that, there's a male, female, and they click together and they build very, very quickly and they achieve a lot of things. Solera Wall is the glass equivalent of IMP, right? So you can see there's no framing here at all when you look at the image on the left, because we've got a thicker spacer on the two panes of glass. We can make them male and female, again, analogous to IMP, and have them click together. Very quickly show you how it's done. The image on the left, the horizontal detail, you've got tongue and groove design, and they click together and they stack. Right? And how do we stack them? You look at the image in the middle where it says the sill intersection, right? That L-shaped bracket at the top there carries the load of the glass and transmits it back to the primary structure. So there's no limit on how high you can stack them. That little T there, talk about an easy way to install, put up two panes of glass, reach in with an Allen key, turn those little T's, and they're now locked in place, right? And the image on the right, rain screen, right? We talk about air penetration, we talk about water penetration, especially, but this is a true, even though it's frameless, it's a true rain screen design. And it's been tested, and we know that you're not going to have any water penetration, right? This is an image of a project we did recently, big project up in Canada, up in Montreal, Solera Wall on mass timber, which is kind of hot these days. I know this is metal and I should be showing that, but it's such a beautiful application. But the bread and butter for Solera Wall is on steel, right? This is a high-tech application, lots of natural light. They've got their sales and technical team down one end of the building, and this is not your typical cubicle farm. Because of that natural light, it's a place that people want to be in. Again, a Solera Wall on steel application, another tech firm. This is a big supplier to NASA and to Tesla. And there's that glow again, that nighttime glow. But look at the image in the bottom right-hand corner. There's not a single artificial light in that space, right? This photograph is full spectrum natural light from the sun, completely free and completely glare-free, right? That is it. That's the main part of the presentation. And I'm just going to slide through the gallery now. This is a perfect time for people to ask questions while I run through the gallery. So let's hear them.
Well, I'll break the ice, Joe. This is Robert again.
Yes, sir.
So one can imagine, again, with regard to the insulation, one could imagine that the translucency does offer a significant, I'll say a dissolve reduction on the load to the HVAC system, because now there's not
Yes.
any of the direct. Is there a percentage that you're comfortable sharing out there that a translucent system versus a transparent system can offer?
That is a great question, Robert, and it's interesting as I never get asked that question. And the interesting thing is that I told you we use a glass fiber veil to do the actual diffusion. Okay, the
Yep.
glass fiber veil also significantly reduces the amount of light and therefore the amount of heat that's coming into the space. Sometimes it's the model that drives, like the daylight model that drives what visible light transmittance should be. But sometimes it's the solar heat gain. Sometimes it's the HVAC engineers that say, I want a maximum solar heat gain of 35, 0.35,
Yeah.
right? And that's what we'll put for the visible light transmittance. So, I mean, we could go as high as like an 80% reduction in solar heat gain. A visible light transmittance of 0.2 is not all that unusual, especially if you have a significant amount of glass. So yeah, if the HVAC people are saying I only want this much, this many BTUs to come into the building, we can control that. Like it's a knob that we can turn to decide how much light and therefore how much heat we're going to bring in from solar heat gain. I
Cool.
don't know if we have the project here from Melissa. Do we have Kuwait on here?
Yeah.
Yeah, this one. This is Kuwait University. It's 40,000 square feet of sawtooth skylights. And obviously we're keeping heat out in this particular scenario. And that's exactly why they did it. First of all, they wanted it to be glare free, but they need to keep the heat out of the building. And
Sure.
so they went with a relatively low visible light transmittance series of skylights and to manage the HVAC. And let me throw one more thing in there. It's not just the absolute solar heat gain, it's the placement. It's those hot spots that really give HVAC engineers nightmares, right? It's really hot over here, it's not hot over there. So now they have to redistribute the cool air and the warm air. So if you take away the hot spots, you're also improving the operation of the HVAC. Did I answer your question?
You did. It's
Okay.
fabulous. Thank you. Thank
Okay.
you.
No
So one of
problem.
the comments as I was walking through and looking, and this is maybe a good segue to your gallery, is by the glazing and from the design standpoint for architects now, the what I would call designing to the negative comes into play now, because if we jump back a number of years to illuminate a building when Mother Nature turns the lights off, were pot lights outside. And so you got the spotlight effect illuminating part of the building. But
Hmm.
now with the translucency, to your point, there was that one Volvo location beyond the ice rink. The Volvo auto dealership showed a different view, like the blue glowed more so. So now you've got the true 24-hour aesthetics that they may not have had before.
Yeah, and that was very conscious. And we've got a program with Volvo. It wasn't just the one dealership. This is part of the whole. They call it the VRSE, Volvo Retail Sustainable Experience. So we're a primary component in achieving what they're trying to achieve. And when you hear the feedback from them, they talk about that glow at night for sure. So I appreciate you spotting that. But the other part they talk about is how incredibly comfortable it is. Actually, Melissa has it as her background screen. They talk about how incredibly comfortable it is when they're in there. So customers tend to linger because they're not being bothered by the glare.
Yes.
They've got the full spectrum natural light, which you need because the car in the showroom needs to look the same as it's going to look in your driveway. But you don't have that painful burning light that comes from the usual fishbowl design in a car dealership.
Perfect. And it's fabulous to see, and this is for all the Americans on the, to apologize, but quite the technology shift from the Royal Bank of Canada gold building and that aspect.
Right.
So
Right.
I tried to paste into the chat here a picture of that for everybody on here of the Royal Bank of Canada. That wasn't glazing though, was it?
I'm not 100% sure. So were you able to get it into the chat?
No, I was not able to for some strange reason. Anyways, just a bit of trivia for the folks that, if I can, while you go on through your gallery, I'll see if I can get it somewhere in the chat to show people this gold building that went up for sale. To your point of future value, the real estate is one thing, but the value of the 2,500 ounces of actual gold that were used on the exterior of the building has jacked up
Oh,
the
right.
price of the building just for whoever wants it, right?
Right. I
So
know.
be
The
careful
one
of
on
what you
Bay Street.
choose.
You mean the one on Bay Street? Yeah, gotcha. Yeah, we definitely want to share those images at some point. I want one of the reasons that I show Kuwait University, and this one is actually in Tatarstan in Russia, is that I want to make the point that even though we're up here in Nova Scotia, we've done projects all over the world and in some really complicated, difficult places. So Arizona is no big deal. That's that's the message. Another one where the glow at night. This one's in downtown Omaha, the Performing Arts Center. It becomes a beacon for the community, and it's a gorgeous interior. Again, really high end, but this is meant to be an aspirational presentation for the people who are serving a group of a higher end customer. This is Minneapolis St. Paul Airport. We've been building for, I think, about 8 years now. We're on, or maybe even longer, but we're definitely on the eighth phase of the expansion here. And we built it with an explosion proof glass. So we can use whatever glass you want. If somebody wants a particular tint or whatever, or goofy frit patterns, all those kinds of wonderful things. But with a really this is made with a really thick and a laminate glass to be explosion proof, blast proof. There's a larger picture of the arena. Again, I love this image because it drives home those large, sort of unobstructed spaces. Man, you can bring in a whole lot of light with a small amount of glazing, which is the name of the game these days. And it's soft light, and we can dial in exactly like you said earlier, the right solar heat gain coefficient. We do a lot of airports, a lot of big jobs like that. Again, large spaces. Think gymnasiums, right? Think about large community centers. Those are the places where it's really going to stand out. Right. There's another shot of another one of the Volvos. Interesting, they use the translucent to create a transparent frame, right? So they just want to show off a certain couple of vehicles, and they frame it, which actually, a lot of people say, well, if it was all transparent, they could see everything. But with the translucent and the transparent in combination, they direct your eyes towards a particular vehicle that they really want to show off. There's an outside shot. So it just looks like a white building, but it's basically a glowing wall with very high levels of insulation. I think it's R18 is the spec with Volvo. And there's a chat there. Let me see.
I could not load a file, but I put the link, but that doesn't work. So we'll just,
Okay.
if anybody wants to look up the Royal Bank of Canada, just put Royal Bank of Canada Gold Building, and you will see what we're talking about from
That
the.
linked worked, Robert. Thank you.
Oh,
It's
perfect.
working for me. Yeah.
Perfect.
Okay.
So the other question that I had, you were referring to similar to the IMP. So one of the conversations going on now about IMPs and other insulation products is this to meet energy codes of continuous insulation.
Mhm.
So does this wall then classify for a continuous insulation system for a wall?
I'm not sure.
Okay.
Yeah, I'm going to need to check on the exact definition of continuous insulation, and I
No
will
worries.
share that.
You were right there with the rest of us, Joe, right in the midst of this quandary. So this is
Yeah.
something that came over from the residential world
Mhm.
with the exterior foam board being taped at the seams to allow continuous insulation. And then it was rubber stamped in the metal building system world. And there are exterior envelope systems that are claiming they have it, but none of us really do. And so I just thought I would give you the heads up that that might be a question in your future.
I took a note on that for sure. I will definitely look that one up. I
Oh,
just
cool.
don't know the answer
Yeah, no
right
worries. No worries. Just sharing the horror at the same time.
now. Yeah, for sure. Interesting. There's two ways for us to connect to IMP. So vertical applications are the most common. We can either work with a WinTech frame to install in that scenario, or use a transition. horizontal, we can make it, we can have our Solera wall integrate directly with horizontal applications. A lot of the images that you saw earlier are with metal span and Kingspan, but we can do an extrusion to match with anybody's. In Canada, we have a partnership with Norbeck, so we can integrate directly with Norbeck. So just different types of integration with IMP. It's a nice combination, right? Because when you want a building with high levels of insulation and just a little more higher perception of quality, the two go together so beautifully that I see a lot of higher end buildings being built that way now.
Cool.
Any more questions? Anybody out there? A lot of these I'm showing you just so you recognize that we've done projects with big names and big name architects and big name builders and big name building owners and that sort of thing. And is that to show off? No, it's to show that these people trusted us, right? And we did not let them down. There's a very clear message there.
Thank you, Melissa.
Right, gotcha. Yeah.
This is like part of
Butler Building's new standoff so that the insulation doesn't get crushed. Okay, gotcha. I understand.
Perfect.
Yeah, that's it. That's all I have to say. If there's any more questions, I'll be happy to answer them. If not, Sasha, I'll turn it back over to you.
Thank you very much. And we truly appreciate that enlightening presentation.
Well done.
I'm so silly.
Bravo. Well done.
Anyway, no, thank you so much, Joe and the rest of the team for this presentation today and being part of our monthly webinar series. And we also appreciate, again, Advanced Glazing sponsorship of this webinar today. And this is recorded, so if anyone is looking for it to review it again or wants to share it with anyone else, you will find it in the products and services page, available to members only. And we wish everyone a great rest of your day.
Perfect. Thank you, Joe.
Thank you so
Melissa.
much.
And
Thank
as always, thank
you.
you. Thank
Take
you,
care.
Sasha.
Thank
Take care,
you.
everybody.
Bye-bye.